Good day everyone. Today we shall be finding the inverse of modulo using extended Euclidean algorithms. Let's solve these examples. Before we proceed, it is important for us to know that x in modulo n has inverse if and only if x and n are prime to one another. To the first question now, it implies here that we are looking for a number that will multiply 3, say x prime, to give me 1 in modulo 7. And if you remember, we solved this directly using this definition and we got 5 in the last video. Let's see how to get it using Euclid style. By Euclid, this can be interpreted as 7 is equal to 3 times some q plus some r, and if we keep on solving that, 7 can be written as 3 times 2 plus 1. This one telling us that what the GCD is 1. The GCD of these two numbers is 1. And when we get to this point in this style of solving the inverse, we start solving backward. By working the results backward here, we are going to write it such that what we make this one subject of the formula. In this case, we'll be having 7 equal to 7 minus 3 into bracket. So instead of writing minus, I'd like to leave it as plus, but I will give the minus to this number in the bracket, which is 2. And since we are solving in modulo 7, it means every multiple of 7 we get here becomes 0, meaning this is equal to 0 plus 3 into bracket minus 2, and this is equal to 1 equal to 3 into bracket minus 2. And if you look closely, you will start seeing that you can see that this is looking like this now, which implies that what my x prime here is equal to minus 2, but I can't have a negative number in modulo 7, so definitely I'll be adding 7 to this, so this becomes 3 into bracket 7 minus 2, and this becomes 1 equal to 3 into bracket 5. Here the inverse of 3 is 5. Comparing the two results we've gotten, comparing this with this. So we can now conclude that what our x prime, which is the inverse, is equal to the inverse of inverse of 3, which is equal to 5 modulo 7. I hope that is clear. Let's solve the second question. 2021, this can be written as 2021 times x prime is equal to 1 modulo 4032, and by Euclid interpretation, this will give me 4032 is equal to 2021 times some q times some plus some r. So now splitting 4032 in that form, I get 4032 to be equal to this will go there just once, plus the remainder 2011. Then you shift this over here, 2021 is equal to 2011. We also come here, that's also once, but remainder 10. Then 2011, 10 we go in 2011, that's 201 times remainder 1. And on getting to this remainder of 1, we start solving the result we got backward. Starting with the last one, we start making the remainders subject of the formula. From the last one, I have 1 equal to 2011 minus, instead of minus, I'll write plus. However, I'm trying to hide my minus, so I put inside the bracket, that's 201. Then in the next one there, I have 10 to be equal to 2021 plus 2011 into bracket minus 1. Then this last one there, I have 20 11 this equal to 4032 plus 2021 into bracket minus 1. Name this equation 1, this equation 2, this equation 3 for each solving. Now from equation 1, now we can write 1 to be equal to, okay, let's just write it down first, plus 10 into bracket minus 201. Now if you see from equation 2, 10 is all this, so we substitute for 10. I have 1 equal to 2011 plus all the values there into bracket 2021 plus 2011 into bracket minus 1, and I close my bracket. Then I have here into bracket minus 201. Opening this bracket, I get 1 equal to 2011 plus, when this multiply this, I get 2021 into bracket minus 201 plus 2011 into brackets. This times this will be plus 201. Then this is 2011. This is 2011, so we can add them together. That's 2011 into bracket 202 plus 2021 into bracket minus 201. Taking a good look at this, you see that this 2011 is actually here, and this is the value. So substitute, then I get 1 equal to, instead of 2011, I write down 4032 plus 2021 into bracket minus 1, all into bracket 202 plus 2021 into bracket minus 201. So solving this now, I have, opening the bracket, I have 1 equal to 4032 into bracket 202 plus 2021 into bracket minus 202 plus 2021 into bracket minus 201. So this is 2021, so we can add them together. I get 1 equal to 4032 into bracket 202 plus, now this and this will give me plus 2021 into brackets, adding these two together, is minus 403. I hope that is clear. Haven't gotten to this point, but recall that we are solving in modulo 4032. So every multiple will be 0. Then I get 1 equal to is 0 plus 2021 into bracket minus 403. So 1 is equal to 2021 into bracket minus 403, meaning minus 403 is the inverse of 2021. They multiply together to give me this. However, we can't get a negative number inside the modulo 4032. So change it to a positive number by adding 1432. Then I have 1 equal to 2021 into bracket 4032 minus 403. By so doing, I get 1 equal to 2021 into bracket 629, which implies that our 3629 is the inverse of 2021. Therefore, x prime is, which is equal to the inverse of 2021, is equal to 3629 modulo 4032. So that's how we evaluate inverses using extended Euclidean algorithm. Okay, solve this using this same method and drop your answer at the comment section. I shall check it out and check who's very correct. If you are new to this channel, hit the subscription button, like this video and share. Thanks for watching.